Dear students, I'm Wick Haxton, the Physics Department Chair. Despite the strange times we are in the unusual context of this virtual version of our 2020 graduation ceremony, I'm really delighted to have this opportunity to address you and to greet your families. Over the past 4 years, our Berkeley physics faculty and staff have had the privilege of working with the class of 2020, watching you develop as scholars and as people. You have progressed through a challenging undergraduate curriculum, gaining confidence and strength. As you leave Berkeley, many of you will choose to continue in physics, entering graduate school or starting on the path to PhD level research. Others will apply their training to challenges in education, industry, medicine, or engineering, finding creative ways to improve our lives and society. Our finishing graduate students will also follow a variety of paths. Some will continue their research careers as postdocs. Others have fallen in love with the Bay Area and will remain here to help Silicon Valley industries move forward. Still others will find careers in government and service. All of you will find opportunities to make our world a better place and to lead meaningful and fulfilling lives, provided we faculty have done our jobs. That job is to provide you with the opportunities and motivation to build a strong foundation in physics and as a critical thinker, thereby enabling you to do whatever you deem most important and most interesting for the rest of your lives. We strive to make our students confident problem solvers, deftly able to deal with the increasingly complex world we all live in. We hope you will remember what Albert Einstein taught us about remaining students throughout our lives. The important thing is to not stop questioning. Our graduating students will become part of an extraordinary physics legacy here at Berkeley. Physics has been an integral part of the campus from the university's very beginning, 152 years ago. In 1869, physicist John LeConte was hired as the acting UC president and first UC professor. Since that time, Berkeley has grown to become the most distinguished public university in the history of higher education. Guided by the motto, Fiat Lux, the university's purpose is to create ideas and find solutions that will better the human condition, to be a beacon of opportunity for each new generation. Berkeley strives to combine uncompromising academic excellence with service to the public, with doors open to everyone with the talent and desire to succeed. Physics remains a distinguished part of that Berkeley academic legacy. 9 of Berkeley's 22 Nobel Prizes have been awarded to physics faculty. Perhaps even more significant, another 9 prizes have been earned by our former students. And I should point out, the new first floor plaque that recognizes these 9 students has room for a few more names. Barry Barish, who earned both his BA and his PhD at Berkeley, is the most recent to have been recognized by the Nobel Committee. He was awarded the 2017 prize for detecting the gravitational waves from merging black holes. Barry was also recently invited to campus as the Berkeley Alumnus of the Year. In his acceptance speech, he described coming to Berkeley from a working class family, sent by parents who had not had the opportunity to attend college. He closed with a plea to California's citizens to renew their support for UC, preserving the access to education that allows young people like him to reach their full potential. You students are now part of this rich Berkeley physics history. You came to campus just after the announcement of the discovery of the Higgs boson, culminating years of work by Berkeley's Atlas Group and many others. While you were here, you shared in the excitement of Barry's black hole discovery. New Earth-like exoplanets were identified. The hyperfine structure of antihydrogen was determined. Our experimentalists created the coldest cubic meter in the entire universe in an attempt to understand why our universe contains matter. You heard about time crystals, quantum information, and the emergent symmetries of topological materials. Some of you worked in research groups exploring such new phenomena. We hope you leave Berkeley not only with an education, but with a love for learning, warm memories of your time on our campus, and a passion for making our world a better place. It has been a privilege to have you as students in our department. Yes, we have been your teachers, your guides, but you walked the path, mastered our most difficult courses, and became physicists. On behalf of our faculty and our staff, I thank every graduate for the contributions you have made to Berkeley and welcome you to the distinguished community of Berkeley alumni. All of us congratulate you, and I urge each of you to remember your friends here at Berkeley, returning as often as you can to visit. Now, it is my great privilege to recognize today's student speakers. The graduate student commencement speaker is Arielle Little. I would like to quote from her nomination letter. I think Arielle Little has done so much for the department, especially given that she did her undergraduate and graduate school training here. From my involvement in SWIPS, she has really been the one to keep it alive and motivate people to take on responsibilities so it doesn't all fall on one or two people. I think she provides an excellent role model as a very accomplished, independent researcher making important advances of understanding in the notoriously difficult research area of strongly correlated materials. She taught the 111 lab several times and mentored young students to develop their own research skills and mentored through Berkeley Connect. And on top of that, she has amazing accomplishments outside the laboratory. She raced her first professional cycling race this year. She's been a member and leader of Cal Cycling since an undergrad, actively promoting women in cycling, and been an active part of the Berkeley community at large, doing numerous outreach activities. So thank you, Arielle, for your contributions to Berkeley. Our undergraduate student commencement speaker is Namrata Ramesh. Namrata Ramesh was the driving force in the formation of the STEMinist Chronicles. The intent of this student organization is to increase the visibility of women in STEM fields at Berkeley by documenting and publishing photo essays featuring the women in our community. Resulting poster sessions highlighted the collective and empowered voice of women in science and raised thought-provoking questions about diversity and inclusion in STEM, bringing her ideas to others through activities as a member of our Equity and Inclusion Committee. In founding the STEMinist Chronicles, Namrata initiated an ongoing conversation about inclusion that will continue to influence our physics community for years to come. Namrata is also an outstanding scholar, completing her honors thesis under Professor Naomi Ginsberg, probing the dynamics of self-assembly in gold nanocrystal superlattices using optical and X-ray scattering techniques. Recently, she was selected as a Rhodes Scholar, one of the most competitive academic scholarships in the world. We thank Namrata for her contributions to research and scholarship and for her activism as a leader, volunteer, and ambassador for the physics program. Finally, let me conclude by saying that I look forward to a future day when we can invite all of the class of 2020 back to Berkeley for a proper graduation. Until then, stay safe and go Bears.
Good morning, evening, afternoon, whichever part of the world you are in. First off, congratulations. This is such a huge honor. We finally made it. And our class has been through a lot, okay? We've been through wildfires, riots, power outages, and now a pandemic. It's insane. It's such a surreal moment to be giving a speech over Zoom, let alone give a speech at all. I never thought that someone like me, and someone who doubted her self-worth as a physicist for most of her journey, is now the undergraduate physics commencement speaker. Life is strange. But let me start at the beginning. I was drawn to physics before coming to Berkeley because I just love the grandeur of the questions it's asking about the universe. I also love that something as abstract as the position of an electron has such deep ramifications for the technology we use today. My hope is to take this budding understanding of the underlying structure of the universe and thread it back into trying to solve the pressing problems in today's day and age. Of course, these dreams came crashing down on me when I took Physics 5A in my first semester. I think some of us remember a particular midterm with a particular problem called the space elevator. I can't forget it because it destroyed me. And I remember calling my mother after that and really asking her, Ma, did I pick the right major? should I even be a physicist? And even after I started to do better academically, it was very hard. That feeling of not belonging, of doubt, it didn't leave me for a very long time. And I think it was because even if I had the right answer, I just didn't feel confident enough to say it, um, because all the people around me just seemed so much more confident, just seemed so much more fitting of the role of what it means to be a physicist that I had in my mind, that, I said, oh, they probably know it, uh, even if I knew the answer. And it was obviously extremely daunting to be one amongst a handful of women in most of my physics classes. All of this just made me feel very out of place. And I really spent a lot of time wondering, should I be a physicist? Did I make the right decision? Luckily for me, this slowly started to go away as I started to meet wonderful people in this department. Through my physics classes, I have made friendships that I know will last for a lifetime. We've laughed over our circuits conking for the umpteenth time, over getting problem sets done just in the nick, just before the deadline. Just so many exhilarating, fun, lovely moments that have made this journey so much more exciting. My 2 years in the Ginsberg group have taught me that when wonderful people come together to create a nourishing environment, science flourishes. Creating the STEMinist Chronicles gave me this profound realization that I was not alone in the ways I was feeling. So many other women physicists that I'd interviewed also felt the same way. And so many people in the department supported the project and also wanted to help us. And when I saw all of these different groups of people come together to help me win the Rhodes Scholarship, I realized something. I realized that science is more about just the science, that being a scientist also means being surrounded by great people. I'm forever grateful for the UC Berkeley and Berkeley physics communities, because without these spaces, I don't know if I've ever met all these incredible, wonderful folks. People who I can lean on, people who believe in me, people who inspire me. I met my people at UC Berkeley. And I hope for all of us that we continue to expand our communities, even with the rise of virtual spaces and social distancing. Because not only is this important for us, for our individual successes, but it's at the heart of what it means to be human. But aside from all of that, congratulations. You deserve to celebrate, and go Bears.
Hi everyone, my name is Arielle and I'm graduating with my PhD, which is wild because I actually did my undergrad here too at Berkeley, and to be honest, I can't believe I'm finally out of here. It's truly an honor to speak to you all from the comfort of my couch. Whatever this is, it's probably a poor substitute for a real ceremony, but hey, at least we didn't have to spend our whole stimulus checks on graduation robes. So before I get started, graduation is less for us and more for the opportunity to express our gratitude to our families, friends, colleagues, whoever your support network may be that helped you get to this point. So I encourage you all to reach out to them and thank them. We are lucky to have them. So I struggled with this speech because it's hard to be celebratory these days for obvious reasons. We've all been hit by the pandemic in different ways, and even now the future is uncertain. I admit that I was not sure what to say apart from, I hope this finds you safe and healthy. And well, true, that's a bit cliche at this point. So I decided to start out simply reflecting on my own time at Berkeley. I actually started at Cal as an intended English major, but because I was an undergrad in the wake of the last economic crisis, let's be honest, I was scared, and gaining some technical training seemed like a good idea. Of course, instead of doing something economically smart like computer science, I enrolled in physics classes. I soon realized that doing science had some commonalities with studying literature, for example, the desire to ask hard questions and really get to the bottom of things, and at some point I made the switch, and here we are. It has never been easy, but it has always been a privilege to study at Berkeley Physics. And even while my memories of toiling in the 111 lab or staying up all night to finish problem sets are somewhat distant now, I can't say that just in general, undergrad at Berkeley is tough, like definitely more stressful than grad school. So undergrads watching this, graduating class of 2020, huge kudos to you guys. In your years here, you faced a slew of unexpected events. Recall the political turmoil, wildfire smoke, power outages. I can imagine this has all been like kind of a lot in your 4 short years here, and your final semester didn't end under ideal circumstances either. So I just want to recognize that learning from home is different for everyone and offer extra congratulations to those who have faced additional challenges in making this adaptation. But you all pushed through to the end and you all did it. In thinking about the current unusual circumstances, I realized that my time as an undergrad wasn't exactly a chill time for the UC either. During that time, the cost of in-state tuition increased dramatically, including an around 30% jump. This was received, as you can imagine, with protests from the student body, and this period marked a sort of phase transition in our UC system, from our operations being funded mostly by the state to being funded mostly by student tuition and fundraising. These are unique challenges which Berkeley faces as a top-tier public university, and they will surely be made even more apparent in the context of this present crisis. But so far, I want to recognize how our Berkeley physics community has really risen to the task in the past few months. Our administrative and student services staff continue to support us tirelessly and have rearranged huge events to happen virtually. Our facilities workers keep our building safe and receive our packages. Our geoscience lecturers and our faculty have demonstrated immense creativity in moving all instruction over to virtual over the course of just a few weeks. So whatever comes next, Berkeley Physics will persist in our joint mission of education and research. In fact, it was these great people making up the department that encouraged me to come back for graduate school. Don't get me wrong, it's not perfect here, and we have a long way to go in some areas. But what I have appreciated is that I know that there are people here who care about making it better. I was lucky to have an incredible cohort of graduate students. I had the sense, even from just the prospective student weekend, that my classmates at Cal would be not only talented scientists, but brilliant people. We all came here to do cutting-edge research, but my colleagues have all had different and interesting paths to and through grad school. Some had parents who were physics professors, and some were first-generation college grads. Some jumped into research right away, some taught hundreds of undergrads, and some did both. Some of them started their families during graduate school. Some had hidden talents. Some helped revamp education in the department. Some pushed back on the department to confront challenging issues. And some of them led or founded our student organizations, participated in student government, and even occasionally in political advocacy. So getting your degree, getting your papers published, winning fellowships, all of these are widely recognized in our field, but these less celebrated accomplishments, like the ones I just mentioned, have also shaped the physicists you are and will be going forward. So I celebrate these too. In grad school, I learned so much from these colleagues of mine, but also from my mentors and research advisors. I owe a great deal to a few people who invested in my success and hopefully have done okay. In the lab and in the office, I learned how to look for the right questions to ask, how to take a project from start to finish, when to pull the plug, how to navigate collaborations and ask for help. I filled many doers, adjusted many mirrors, and inadvertently memorized the Berkeley license number for the LabVIEW software. I also learned to always include jokes in presentations or speeches, even if said speeches are done from your home with no audience. So now we are all launching our careers from Berkeley Physics, and whether your path forward lies in science or elsewhere, you are a physicist now. Sorry. And the training you got here will take you far. Finally, one thing that the past few months have really laid bare is that not even scientists can operate in a vacuum. I think at Berkeley we've always been aware of this. Like it or not, our ability to pursue research is always entwined with politics at some level. In quite a different way these days, it is an understanding of science, medicine, and data that is shaping our daily lives and how we respond to a global crisis. I'm not saying that we physicists have the ability to fix anything, In fact, we quite obviously don't. But I urge you to use your expertise and scientific training where it makes sense, to elevate rational voices and to stay engaged. We need you. So I guess this is just what I want you to keep in mind. Hold the concepts of community, collaboration, education, engagement, and duty close by in your endeavors. Good luck with it all. And if you, like I, did any virtual job interviews while wearing pajama pants, I hope you get the job. Be well, everyone, and go Bears.
Devin Allen Agrawal, Annette Michelle Brachidi, Jacob Laverde, Guillaume Shippey, Elisaveta Tremesina. Aaron Ali Basharain, Zelly Chen, Adam Ryan Corbo, James Allen Hansberry, Armand Edward Hashimita, Chiolim Im, Justin Andre Joseph, Nadim Kiever, Hughes Landsberger, Ryan Lee, Yan Liang, Aaron W.F. Lloyd, Angel Javier Jr. Marcial, Maxwell McAllister, Fadi S. Nakia, Kyler Chase Bernardo Natividad, Lisa Min Nguyen, Alexis Andre Palacios, Salmi S. Shrokari, Noah James Stevenson, Alexander Lee Takomi, Joanne Tan, Shonkai Tong, Laura Gisela Villarreal Perez, Luciana Vinis, Giovanni Vizcarra, Maya Alicia Vanas, Graham Glazier Woolley, Ina Zhu, Yuyong Zhu, Lizzie Zhao, and Xingzi Zhao. Aroni Arkaya, Miguel Aguirre, Kazbak Alimov, Titus Amza, Rex G. Burgesson, Charles Edward Bobbs, Alec J. Bonnet, Mason T. Braun, Frank L. Bruni, Ian Torazuchi Agage Campbell, Todd L. Cheney, Ada Chang, Ho Yin Chow, Gianni Chen, Stone End Chen, Sean F. Clayton, Elizabeth D. Coda, Peter Gregory Connick, George Herbert Crowley, Ryan J. Dana, Mark Davis, Evelyn DeGarros, Preston Joseph Dix, Tristan Alec Dillman McDougall, Connor Dolan, Aaron Michael Elrich, Alexander C. English, Nathaniel M. Irwin, J. Yoon Yu, Gail Flores Evita, Chingam Fong, Logan Foote, Andres Antonio Franco Valiente, Gino Gabella, Robert Edmund Garbett, Sophia Gaines, Niela Gross, Jinan Timothy Cho, Clay Halbert, Valerie Shea, Baichung Huang, Heather Jackson, Samuel Berkeley Johnson, Wyatt Joyce, Nirvan Kira, Ted Andrew Kumgal, Sarah Y. Kwan, Julie Lai, Benjamin Lang, Nathan Jeremy Lee, Ryan Lee, Mingyu Lee, Siyang Lee, Joshua Lin, Tiffany Liu, Andre Londono, Jessica McFarlane, Mario Ten Markwart, Hunter L. Martin, Connor Jeffrey McWord, Danielle Mellies, Adam Z. Molnar, Dhruv A. Mooley, Joseph Eden Natal, Samuel Gnoggle, Timothy J. O'Hanlon, Ezekiel Storm Olin, Laura Celine Ostertag, Benjamin O., Melissa Lucille Palmer, Richard Pan, Longsung Park, Sophie Emmeline Parsons, Akash Patel, Diego A. Pena, Isabella Alexandra Pena, Nicholas B. Pickett, Namrata Ramesh, Liang J. Ren, Armando Reynoso Jr., Luz Dalia Robelero, Joseph J. Rodriguez, Nicholas Rui, Faizan Ahmed Samad, Ruben Santara, Andrew B. Schloss, Abhimanyu Singhal, Yochi Song, Brian Taylor Stone, Jackson Z. Stewart, James P. Sud, Chu Sun, Langston H. Zwicky, Matthew James Thompson, Chancellor Tran, Jack Troby, Alexander Vereshi, Neil Venugopal, Jiang Wang, Zilong Wang, William H. Weiss, Matthew Albert Worden, Christopher K. Yang, Zhabao Yang, Zhitong Yang, Zhenhao Yu, Jiming Yu, James Andre Zendeas, Hongmin Zhang, Menyang Chang, Catherine P. Zhao, Zihan Zhao, and Noah Grayson Zisser. Congratulations to you all. Nicholas Joshua Cinco, Emma Grace Deist, Daniel Andre Gardizalba, Neil Glicken, Donez Joaquin Horton Bailey, Christopher Matthew Leopold, Alwina Liu, Ashrita Mangu, Gregory Donald Meyer, Il Yun Na, Zachary Richard Pagel, Eric Kenneth Parsonet, Elizabeth Peterson, Vincent Paul Sue, Julian C. Wolfe, Arino Amy, Shannon C. Haley, Chao Ju, Ezra Douglas Lesser, Yang Liu, James Hamilton Parks, Morgan E. Presley, Nicholas E. Sherman, Jack Dylan Spilecki, Conrad Holland Stansbury, Kenneth J. Vetter, and Elizabeth Rose Wildenhain. Congratulations to you all. Christopher Nelson Akers, advisor is Raphael Busso, Entanglement and Geometry. Brian Amadeo, advisor is Marjorie Shapiro, A search for new physics in multi-jet final states of pp collisions at square root of s equals 13 TeV using the Atlas detector at the Large Hadron Collider. Kyle Boone, advisor Saul Perlmutter. Improving cosmological distance measurements with type 1a supernova from pixels to dark energy. Stephen Drapeshow, advisor Feng Wang. Optical studies of electron-phonon interactions in two-dimensional and one-dimensional materials. Emily Duffield, advisor Marjorie Shapiro. Observation of the electroweak production of two W bosons with the same electric charge in association with two jets in pp collisions at square root of s equals 13 TeV with the Atlas detector. Neil Geckerwald, advisor Adrian Lee. A measurement of the degree scale B-mode CMB angular power spectrum from the polar bear experiment. Ian Halpern, advisor Raphael Busso. Information in, on, and from the spacetime. Adam Levine, advisor Raphael Busso. Energy and entropy in quantum field theories. Zhenglu Li, advisor Stephen Louie. Electron-phonon coupling from GW perturbation theory and electronic and magnetic properties of novel two-dimensional materials. Lee Martin, advisor K. Brigitte Whaley and Irfan Siddiqui, quantum feedback for measurement and control. Sean O'Kelly, advisor John Clark, the microstrip squid amplifier in the Axion dark matter experiment. Dragush Poternike, advisor Ehud Altman, many-body quantum dynamics and non-equilibrium phases of matter. Vinay Ramesh, advisor Irfan Siddiqui, quantum simulation with superconducting circuits. Sean Ressler, advisor Irfan Siddiqui, towards more predictive models of galactic center accretion. Daniel Rizzo, advisor Michael Cromie, tailoring the local electronic structure of bottom-up synthesized low-dimensional organic nanostructures. Cleo Sleater, advisors Stephen Boggs and Stuart Bale, measuring the polarization of compact objects with the Compton spectrometer and imager. Aaron Saz, advisor Joel Moore, transport and topology in strongly correlated two-dimensional systems using techniques from one dimension. Alex Takeda, advisor Vivek Shende and Mina Aganich, develops in the mathematics of the A model, constructing Calabi-Yau structures and stability conditions on target categories. Yuguang Tong, advisor Stuart Bale, electron scale processes in the solar wind and magnetosphere. Hale Horatalu Balch, advisor Feng Wang, optical investigations of intermolecular electron dynamics in low-dimensional materials. Eric Allen Copenhaver, advisor Holger Muller, tune-out measurement in lukewarm lithium with phase-patterned atom interferometry. Lugoya Georgievich, advisors Stuart Bale and Carl Schroeder, interaction of higher-order laser modes with underdense plasmas. Fang, advisor Dan Stamperkern, explorations of spin excitations and dynamics in homonuclear and heteronuclear spin 1 atomic classes. Stephen Matthew Gilbert, advisor Alex Zettel, two-dimensional boron nitride and related materials, synthesis, vacancy formation, and applications for nanopores and nanomachines. Benjamin Aaron Horowitz, advisor Uro Stelchek, optimal reconstruction of cosmological density fields. Eric Hunter, advisor Joel Fagins, cavity and microwave experiments on electron plasmas. Sean Alexander Louret. Advisor Dmitry Budker. Magnetometry and imaging with nitrogen vacancy centers in diamond. Stephanie Alexandra Mack. Advisor Jeffrey Neaton. Manipulating materials, electronic and topological properties of chemically and structurally complex materials. Nityan L. Nair. Advisor James Anelitis. An exploration of quantum materials from topological semi-metals to antiferromagnetic memory. Chin Sherm Ong. Advisor Stephen Louie. Electronic and optical properties of materials for energy-related applications. Nicolas Sandro Salzetta. Advisor Yasunori Nomura. Holography beyond ADS/CFT. Brian Shavitsky, advisors Alex Zettel and Shaul Aloni. Hyperspectral imaging and machine learning for nanomaterials characterization. Simca Boma, advisor Francis Hellman. Non-collinear magnetism and magnetotransport in amorphous transition metal germanium thin films. Thomas P. Darlington, advisor Norman Yao. Localization of excitons due to inhomogeneous nanoscopic strain in monolayer transition metal diacolines investigated by NanoPL and NanoRaman microscopies. Jeanette Dickinson, advisor Marjorie Shapiro. Atlas measurements of the Higgs boson coupling to the top quark in the Higgs to diphoton decay channel. Michael Fang, advisor Michael DeWeese. Stochastic analog computation for machine learning. Eli Kitnidis, advisor Martin White. Cosmic cartography, mapping the universe to next generation dark energy experiments. Sylvia K. Lewin, advisor James Anelitis. Arielle Little, advisor Joseph Orenstein. Symmetry-sensitive optical probes of quantum antiferromagnetics. Vijay Narayan, advisor Surjit Rajamandan. New frontiers for physics beyond the standard model. Jihua Oh, advisor Ori Ganor. Line defects in 5D gauge theories. Adam Stuk and Sheng Wang, advisor Feng Wang, scanning near-field optical microscopy of low-dimensional material. Congratulations to you all.
Hello and congratulations, class of 2020. I'm Frances Hellman, your dean, and I so wish I were with you all in person together with your families and loved ones who also deserve this day, because I really want to celebrate your amazing accomplishments. I know how hard this pandemic has been on all of you, and I want to thank you for the tremendous resiliency you've shown in the face of upheaval, change, and worry. You were a brilliant, accomplished class before all of this, and you are even more amazing in my eyes now. I will always remember the class of 2020. I won't just remember you for being the COVID class. I will also remember you for being amazing students and scientists. I may be dean, but I'm first and foremost a physicist. I love nothing more than getting to know students, being inspired by your questions and ideas, and finding ways to support you in answering them. Having met you in class or in student forums or in my lab, I'm confident that you are going to go out in this world and help solve its problems. I may be very biased, but I believe that your physics training makes you uniquely equipped to break down problems that can lead to great, world-changing discovery. The world needs you more than ever. And if there's one thing we've learned in 2020, it's that science is paramount, and we're all better off when we understand how we got here, what we're made of, and what laws govern our universe. Whether or not you stay in the field of physics, I will hope you will always be curious about the world around you, and that you'll share that love of science and scientific thinking with the people in your lives. Now, on behalf of the College of Letters and Science, I'm going to confer the degrees. The bachelor's degree is conferred by the College of Letters and Science at Berkeley after a program of study usually requiring 4 years, which includes both general studies, broadly distributed as to field, and specialized studies at greater depth within a major subject. The aims of the bachelor program are twofold. First is to equip the candidate with the benefits of a liberal education in preparation for whatever leadership in society he or she may be called upon to exercise, and to equip him or her for further intellectual growth, either in formal academic study, as a graduate, or by employment. The degree of Master of Arts is awarded by the Graduate Division of the University of California after a program of study, usually requiring 1 or 2 years of study beyond the bachelor's degree. In the master's program, the emphasis is upon coursework at an advanced level, often in preparation for teaching of the major subject at a college level, but sometimes in preparation for employment that requires a deeper knowledge of the specialty. The degree of Doctor of Philosophy is awarded by the Graduate Division of the University of California after a rigorous program of study and research, usually requiring at least 4 years of study beyond the bachelor's degree. In the doctoral program, the candidate must complete advanced coursework in the specialty, must pass 1 or more advanced examinations set by committees of the faculty, and must carry out extensive original research in the specialty in preparation for the writing and defense of a thesis. The doctoral program is highly individualistic and requires commitment to an extended effort of unpredictable outcome. The doctorate prepares those who attain it for a career in college or university teaching and research, or for carrying out independent research at a comparable level in other settings. So, if you are able, would all the candidates please rise from your comfortable couch for just one moment? By virtue of the authority delegated to me by the Regents of the University of California, I hereby confer upon you the degree of Bachelor of Arts and of Bachelor of Science, the degree of Master of Arts, and the degree of Doctor of Philosophy, and all rights and privileges pertaining to that degree. You are all scholars, and I welcome you to the ranks of educated men and women. Fiat Lux.